Welcome back, fellow mathematicians. You are back with Miss Ledbetter, and we are ready to do some more math. Today we are focusing on solving systems of equations algebraically. We've already discussed in class a system of equations that we have more than one equation working together, and finding the solution of that system is where do those two lines intersect on the graph, or what point do they have in common. So now we're going to look at how do we find that algebraically rather than graphically. And so you need to be recording these notes in your interactive notebook on page 13 as we follow along for now our unit 3 for systems of equations. So there are two different methods that we're going to look at for solving this system of equations. The first method is substitution, and it's simply called substitution because we will actually end up substituting one equation into the second equation. So if you notice the first equation in this example, we have y equals 2x minus 5. It's already solved for y. We already have one variable by itself. So therefore, we're actually going to take the value for this y and substitute it into the second equation for the value of y for the second equation. So then when we plug it in, we're going to end up with a joint equation where 3x plus now the original equation for y, which is 2x minus 5, is now equal to 10. And then solve this new equation as it is. So go ahead and simplify by combining like terms. And with the like terms, I have 3x plus 2x, which is going to give me a total of 5x minus 5 is equal to 10. And then solving that in the same way that you would solve every other, you're going to add 5 on both sides. So then you would have 5x is now equal to a positive 15. Divide both sides by 5, so therefore x is equal to 3. Well, now that we know x is equal to 3, we're looking for the corresponding y value. So I'm going to take my solution for x and I'm going to plug it back into one of the original equations. It does not matter which one. I would probably go with the first one because it's already solved for y, and it'll be a lot easier to find our solution there. So if I plug that in, plug in the value for x, I would now have y is equal to 2 times our new value of x, which we said was 3 minus 5. And then solve that. 2 times 3 is 6, minus 5 is going to be 1. So therefore the value of y is equal to 1. So this system of equations has a solution with the point of x is equal to 3 and y is equal to 1, and that's our final solution. So that's the substitution method. The second method for solving a system of equations is called elimination. And they call it elimination because the goal in this method is to eliminate one of the variables altogether. So if you notice in the equations as they are already set up, they're already in the form of x plus or minus the y equal to a number. So they're already in the same form, so then we can simply just compare their coefficients for each of their variables. So we have 3x and 5x, but we have a positive 2 and a negative 2y. So having it in this form is already set up in such a way that if we simply add these two equations together, this positive 2y and the negative 2y are going to cancel each other out when we add the two equations. So that's exactly what we're going to do. So I'm going to add these two equations. So 3x plus 5x is going to give me 8x. And then a positive 2y and a negative 2y, those are going to cancel each other out, leaving me with 0 is equal to 7 plus 1 is 8. So now I have a new equation of 8x is equal to 8. So therefore, x must be equal to 1. Pretty simple. So again, now that I know the value of x is 1, I'm going to take it and plug it back into either one of the original equations. It does not matter which one. I'm going to go with the first one just because I don't know, I think maybe it looks easier. Doesn't matter. Really doesn't matter. So then I'd have 3 times my new value of x, which I said was 1, plus 2y is equal to 7. 3 times 1 is 3 plus 2y is equal to 7. And then solve the equation again, just like you would normally. So I would subtract 3 on both sides. So then 2y is equal to 4. Divide both sides by 2. And therefore y is equal to a positive 2. So then my solution for this system of equations is when x is equal to 1, y is equal to 2. So there is their corresponding point that they share, that they have in common. Let's look at one that's a little bit more complicated with the elimination method. It is easier once you have them in the right form. It's very quick and easy to do the elimination method. However, notice in this example, I do not have a variable that's already set up to be eliminated. 2x and 4x will not cancel. 3y and a negative 2y will not cancel. So therefore, in this situation, you will have to multiply one or both equations so that you would then have the coefficients with the one positive and one negative of the same value. So let's see. If we take, let's say that we wanted to eliminate the y because we have a positive 3 and a negative 2. It's already set up with one positive, one negative. Let's eliminate the y variable. So in order to do that, I would have to multiply the first equation by 2, and I'm going to multiply the second equation by 3. So whenever I multiply the equations, I'm going to multiply everything in the equations. So then my first equation is now going to become 4x plus 6y is equal to 8. And then now the second equation, whenever I multiply that by 3, if I can get my arrow to be straight, multiplying the second equation by 3, I would get 12x minus 6y is equal to a negative 24. Now I'm ready to go ahead and eliminate because now I have a positive 6y and a negative 6y. So whenever I add these two equations together, those are going to cancel each other out. So I'm going to add these two equations. So if I have 4x plus 12x gives me 16x is equal to a negative 16. And therefore x must be equal to a negative 1. And again, same story, second verse. If x is equal to a negative 1, I'm going to take it and plug that back into one of the original equations. It does not matter which one. Pick up whichever one you want. Again, I'm going to go with the first one. I don't know, just because it came first. Either way, whatever. So 2 times my new x value of negative 1 plus 3y is equal to 4. So 2 times negative 1 is a negative 2 plus 3y equals 4. Adding 2 on both sides. So 3y is equal to 6. And then therefore y is equal to 2. So this system has a solution of a negative 1, positive 2, and that is the corresponding point that they have in common. If I take the x and the y values from any of the solutions that I found and plug those numbers into the original equations that I started with at the beginning, both equations will end up resulting in the exact same value that I have originally started with. So if I plug it into the first equation, the x and the y, then my solution will equal 4. If I plugged it into the second equation, then it would simplify and equal to a negative 8. So that's how you can check to make sure that your solutions are in fact correct. So now it's your turn. So here's a couple of examples for you to try on your own. So take your time. Go ahead and pause the video if you feel like you need some additional time. Use whichever method you would prefer. You will see at various times, depending on who's asking, the professor or the textbook or test may specifically say use substitution method or use elimination method. Ultimately, it really makes no difference because you will result in the exact same solution no matter which direction you go, which method you choose. So choose whichever one is going to be the best suited for this particular example. So for example, number 1, it's already solved for y, so therefore I'd probably do the substitution method. But if you want to do elimination, that's totally fine. Make sure that you set up your equation so that the variables are aligned with each other when you do the elimination method. So then number 2, all of the variables are already set up. I have a positive 4y and a negative 4y in those two equations. So I would do elimination method because it's already set up in that manner. But either way, it does not matter. If you want to solve one of the equations for one of the variables, either variable x or y, and do substitution method, that's totally fine because you will still result in the exact same solution. So either method, whichever you would prefer. So hopefully you've had the time for you to be able to work these out. So on example 1, you should have gotten the solution of 5, 7. X is 5, y is 7. And then for problem number 2, x is -1 and y is 4. So those are the two solutions. If you did not result in those two solutions, make sure that you ask. Write those down on your notes to self as you're working through these. Write down any questions that you might have so that we can go over those and address them in class tomorrow. Thanks for watching, and I hope you have a great time. We'll see you next time.